Hello and welcome back. In the previous video tutorial, we'll learn how to use the operation modifier in Would Be to adjust the settings for contour and depth of cut. And in this video, we're going to talk about the corners and machining strategies. So in order to continue with what we have done before, I'm going to just reset a few things that we did because we actually don't need them for this rough cut. For example, the Z cleanup, I'll set it back to 0. We also don't need the finish pass, so we're just going to have one pass. And for the depth of cut, I'm going to keep it 50%. So we're going to have the tool going 2 times around the objects to remove the material. All right, so now let's talk about the corners first. And under the corners, you can see the settings for external corners and inner corners, or exterior corners and interior corners. So in this video, we'll focus on the external corner, and that's very easy. You have two options. So let me show you from the top view. So as you can see, when it's the using the arc, move is going to just go around the corners with ensuring that the tool is actually always stays the same distance at the corner, so it moves around the arc with the radius of the tool actually. And you can also change. You can also use a line move, or just changing to a bitangent, and that's what it does is extend the tool pad at the corner, so it can go with a line move, maintaining the distance from the corner as the tool radius, so the tool doesn't cut the corner. Okay, so that's about the corner, and we'll look at now the machining strategies, which is specific to the operation type that you're modifying. Right now we are modifying a two-dimensional contouring operation, so what you see here is relevant to this operation. If you modify a different type, like a waterline contouring or surface milling, then these options will be different. In case of 2D contouring, you can select between two different strategies. The first one, which is it's called horizontal contouring. It basically means that the contour stays in the horizontal plane. So if I run the simulation now, we see that the tool is moving on the first contour, on the first level, and then when it finishes, it dives to the second level. I believe this is where the level changes because we are half through in the pad. Yeah, so now it has gone down into the next level. And the reason is like doing reverse is that we are allowing the tool to go in both directions. So in here you have a choice of doing bidirectional milling or synchronized milling and reverse milling. The synchronized milling will force the tool to move in the direction of cutting. So basically, if you imagine the tool is rotating counterclockwise, it's going to throw the chips behind the tool, and sometimes it's called also crimp milling. And the other one is just reverse of that, which is actually called also conventional milling, and that is basically going in the direction of reverse with respect to the cutting tool. So that means that the tool is going to throw the chips um, in front of it. So you basically can choose between these three strategies or milling directions. The second strategy for the two-dimensional contouring is called helical contouring. And what it does is basically combine all the contours and all the layers into a single helical movement. So I'm just going to choose the helical contouring, and maybe we can see that better in elevation. And you can see now the planes of the contours are not horizontal anymore, and basically tool will start at some point which has the highest depth, and then it goes gradually down until it reaches to the bottom of the part. It makes sure that always you have kind of horizontal contour at the bottom. So we might add one more pass. So right now I probably have 3 passes instead of 2, just to make sure that I'm going to cut all the way down. But this might be better strategy for most cases actually, and I personally prefer this. It doesn't leave a mark where the tool actually goes down direct. It looks like basically a spiral. The last thing we want to talk about is the sorting, and that has to do with the way that the contours of different parts or different features are milled. If I go back to the horizontal contouring, the options for sortings are by cavities or by layers. So the default is your tool is going to mill around each part, and then it's going to jump to the other one. Let's speed up a little bit. So it just finishes this one and then does the 2 rows of the other one. So it's now second contour, and then it moves to the next one, and so on. So it basically cuts the part one by one. Now, if I choose by layer, what's going to happen is that the tool is going to mill the first layer of all parts, and then it goes back again from the first part and does the next layer for all parts again. So you can see now the tool moves. Once it finishes the first layer, it just moves to the next part. So we kind of like cut 50% around all the parts first, and then we're going to then cut the next 50% for the cuts. This will ensure that your parts will stay on the sheet, and is sometimes better because you make sure that nothing will detach suddenly from the sheet, or you might have different reason to use this. It just makes the toolpath a little bit longer, but I'm pretty sure there are benefits in this, and that you might consider that. So that was all about the machining strategy. I hope you now can take advantage of different options that we have here and optimize your toolpath. There are more into this, which we're gonna look at it in the next video, and it has to do with the latent links and the way you basically engage with material and retract from it. So please stay in touch, and we'll see you next video.